Give me a sec. I'm gonna find my slides. Yeah, the few that I have anyway. So this set of slides is a rip-off of what I did for Package Source Con like a year ago, but I have a bit more than this to show, and I've been making progress anyway. So this is about DeforaOS on the desktop on NetBSD, as many other systems where it actually works, as I'm gonna illustrate. So this is the environment that I am using right now for not every application, but like the system itself, as you may have seen. I can show you again. So I have a panel here, which is which comes from Defora. I'm using Window Maker because it works with just about any window manager anyway. And I'm going to show to you what else it features. So this talk is going to be composed of an introduction, some slides, the demo effect, and then I will tell you where to complain if you didn't like it. All right, so I'm freelance. I just gave a talk about HBSD. I'm a NetBSD developer too since last year, and I started the DeforaOS project in 2001, so it's going to be like 13 years. Wow. But it wasn't looking the way it is now at the time. The project in its current shape is about 10 years old. So it's been a long time. It's been a lot of work. It's open source since the beginning. So the beginning was sometime in 2005-04. It was born from my frustration with existing software. The main thing that really pissed me off at the time was I was studying in a school in France, in Paris. I had a workstation at home and my laptop. I was going to school with my laptop. I was reading news. I was coding, whatever, and then I was going back home, and I wanted to use my desktop because my wrists were hurting from coding too much, and my neck was hurting from not standing properly on my laptop and so on. So I wanted to use my desktop system, except I couldn't because it was very cumbersome to synchronize all of my news files, my source code, everything from the two machines. And as I just mentioned, when you're using CVS or some tools like that, you never have all of your local changes inside the tree, or not always everything. So you cannot easily just push to a central repository and then pull again. And more importantly, it's not transparent. So the initial goal of this project is to make all of this transparent. And I have it working as a prototype to some extent. So really it's about ubiquitous computing and seamless networking. So you just have your device, you have a pool of devices, and you have all of your data that's shared across, and potentially your applications can even migrate from one device to the other. But anyway, this is not exactly what I'm going to show right now. So the system as a whole is therefore made of 3 different parts. There is the distributed framework, which I just mentioned, which is here in the second item. I have a self-hosted capability to some extent. The system does not have a kernel right now, so I'm using whichever kernel I find, like Linux or BSD or whichever. The system has a libc, and this part is more about keeping the work that I've been doing at school in place. And then it's an operating system because I'm trying slowly to write every component of the system, but it's not the final goal either. It doesn't have to be a complete system. It's just organized the way that the full operating system would be. So I have, however, a beginning of an assembly and compilation framework inside this part. And to what matters to us today, more importantly, there is a desktop environment. So as I mentioned, I was frustrated with software, the existing software at the time, and still today somehow. So instead of complaining, I just make my own. And then I bend it to my own needs, and well, eventually I wrote almost a complete desktop environment based on GTK, and it works on BSD, on Linux, on MacOS X to some extent, and maybe some other platforms even. So this is all work in progress, and I'm gonna let you know right now how it looks in package source, for instance, because the system is in package source. There's a number of packages which come from DeforaOS in there, which I'm maintaining myself at the moment. In FreeBSD, I'm really lucky somebody is doing it for me, Olivier. Thanks, Olivier. Hi. But in package source, there is all of that right now. So as you can see, there is like about 20 packages. It's mostly based around the desktop, so these are all graphical applications except for one meta package and a couple libraries. Yeah, like 3 libraries. All right, so now in no particular order. Okay, so there is more coming. I want to import all of these, but I'm going to speak about them at some point. So yeah, so what works? The desktop environment has a meta package. It includes almost everything in this package. A lot of the functionality you would expect on a regular desktop is already there in a shape or another. It's still the work of just one person, so please bear with me if not everything is working absolutely right and has every feature you would expect. But really, it's meant as a somehow minimal environment, minimum working environment. So I don't have the ambition to implement GNOME or XFCE or Windows or whatever, but I want to have something that just does whatever I want. And eventually, it let me gain a lot of flexibility, and I can use the system in many different contexts. I'm going to illustrate that also through the embedded development simulator. So, as you may have heard, I've been presenting this system on a tablet device last year, and I'm also trying to get it to run on a smartphone. So it's not only for the desktop; it's also for embedded platforms. It was not the original goal, but since I developed everything in a consistent manner, I could easily adapt all of that for different users, which is another very good motivation for it. So, how it really looks. So first, I have a volume mixer. It looks like this, and I can even show it live, which is probably much more interesting. And it's a first illustration of the flexibility that I have, like just making this evolve the way that I want. So the mixer has a number of different modes. To illustrate that it's really working fully, I can show you the original tool of NetBSD, which is like this and not very convenient to use. So instead, I have this one, and it runs in different modes. So the default one is tabbed. So you have exactly the same commands. So in the outputs tab, you have master, master2, taxel, and so on, except you can really like modify it the way you want, easily, conveniently. Then you have the inputs, record stuff, and so on. And interestingly enough, you can run it in different modes, like here where it's just a horizontal layout. So if you have a really wide screen and you want all controls like a sound engineer console, whatever, you just do this. If you want the same, but with a vertical layout, you do this, select everything, and then you have your your console again. And so you can really easily change that, influence it. And if you want to run it embedded inside a panel or whatever, you can just do this and say you want to embed it in the panel, and here it is. It's in a pop-up over here. So the screen is a bit small right now, so this is not working fully properly, but you get the idea. So it's easy for me to do all of that, to combine applications together, because I wrote everything, so I know how everything works, and I can easily have a consistent style and have everything integrated. So that was for the mixer. As you have seen a few minutes ago, there is a video camera. So this is not the best picture of myself I could have taken, but maybe I can try something else. So this is the camera again, with a live feed of myself, and this is like a live feed of the ceiling. Not very interesting. But as you can see, I have some overlay capability, and it can also scale up. And really, it's meant as a photo application for cameras or as a webcam. So I could take shots. Yeah, and then you can just press on the gallery button, and you have your gallery, and you can watch yourself being a fool. Yeah, and have a bigger preview of it, like this, inside the file browser, which I'm going to mention in a minute. So yeah, let's hide this for now. Okay, so I can. The overlay is not really meant to show off, but more as it's meant to run the user interface, really. So I want to get rid of the toolbar and have everything on top of the screen optionally, like on my actual phone. So this should look good. Yeah, at some point. Now, the telephony application. So I mentioned smartphones. This application is not only for smartphones, and I'm going to illustrate it right now using my actual phone. So I can run it just like this. I just enter phone, and it's going to add this small applet here integrated in the panel, and it also has a couple of sys icons, as you can see. So let's connect. Give me a sec. So that's my regular phone. I'm going to configure it to use USB like a sync and connect mode, as Nokia did. I don't know about the new Windows stuff. Alright, so now it should say it's connected to Mobistar or something. Well, it was just going to say registered, I think. Please work. Is that like the first demo effect of today? Okay. It's strange. I got it to, I mean, it was working all of these years and in the train yesterday again, but yeah. What's going on? So you have the device. Why is this in mass storage mode? No, I have the device here. This one is the one which should work. Okay, it's dead. Okay, let's try again. Or maybe it's command line here. So really what your phone exposes when you connect it to the system is a line like this, and you can, yeah, this should be right. You can connect to it with CU, and then you just say 80, whatever, 80E. So the issue is with my phone, actually. So, okay, so let's just reboot it, and I'm going to illustrate it just in a few minutes instead. Okay. So I'll get back to the telephony application a bit later. You just remind me if I don't. Next, the panel. I already mentioned it a bit. So as you can see, on each side of the screen here, I have a panel with some applets, a Wi-Fi browser, haha. Some information about the system, like the CPU frequency and so on, an embedding area, desktop notifications, a clock, the task list at the bottom, a desktop icon to go back to the desktop, and again, and I can switch desktops, blah blah blah, everything that you might expect. To be more complete, it has a number of applets available, which are listed here. So this is the stuff that I implemented already. It can follow the status of your Bluetooth device. It should show up now. Here I have Bluetooth enabled. I can press again F5, it's going to go away. So it's quite integrated with the system. It works on more than just NetBSD. And as you can see, it has a few plugins available, and it should be fairly easy to make more if you know C. Alright, this is for the panel for now. This is the previous talk. Where are my slides? Sorry. Yeah. Yeah, I have some. I'm trying to be compliant with XDG every time I can. I have a virtual keyboard which I could show also right now. No, it's not here. Okay, I cannot show it. Where are my slides? Here. So yeah, I'm gonna show the keyboard in a minute. I have a help viewer which is based on an HTML widget. Interestingly enough, I have improved it a bit since last time, and over here I should have a shell somewhere. Yeah. This one. Okay, so it looks like this in embedded mode. I will speak a bit more about this later. So I have already integration with some manual pages, so you can browse manual pages in here. And also a bit like what DelfHub does with GTK doc, so you can also browse reference manuals in here, and so on, including for GTK, and so on. Yeah, well, not this one apparently. Okay, so this is for the online viewer, online help, and I have online help for almost every application now. And it works also, if I compile it a bit better, for the system itself. So you can have access to the regular manual pages of NetBSD and so on. I think this was also a project for Summer of Code or something. So that's like 2 projects that are implemented somehow in this desktop. The file manager is maybe what I'm the most proud of right now. So you've already seen a piece of it because I'm using it for the gallery stuff. So this is the file manager in non-embedded mode. I have a bunch of plugins also on the left, which works a bit like the applets we've seen before. So it has a number of different views like this. I can go back to the slash or something to illustrate it. This is the preview mode, where you have you can see pictures directly, so it can work as a photo browsing application. But you can also turn it into something else. With the CVS plugin, for instance, if I go to whichever place that supports CVS, that uses CVS, like my home folder, I should have... do I have anything here? Well, okay, let's use Git instead because it's offline and I know it works. Okay, so DeforaOS is managed using Git. I have a Git plugin here. It's not as complete as the CVS one, but I can simply click here and bam, I have the log. So this is just this is like an IDE just by adding a plugin mechanism to my file manager. And I can say, okay, if this is not a Git repository yet, I can say, okay, create me a Git repository, bam, you have it. And now you can view the log of your own new repository, which is empty, of course, the stylus, blah, blah, blah. You can add files and so on. So really, just by using a small script in a file manager, you have an integrated development interface, which detects makefiles. So if I go back to DeforaOS, it detects the makefile and it tells me, oh, these are the available targets. If you want to run make clean, just go for it. Yeah, and you have your output here in real time. So the file manager is also an IDE. You can also browse pictures, as I mentioned. You can see text files like this, previews of them anyway. So it's really handy. You can do. This one is more for debugging. It just displays whichever selection is currently done. It has support for subversion. I'm trying to write something for RCS too. I have trash support through a plugin also. It's not mandatory, but you can have it here. So in my trash right now, I have 2 files, and I can restore them or delete them definitely, and so on. The same code works for backupping. So this is really the same code as the trash. Just instead of deleting, I'm archiving somewhere. So this is also another very new and complete functionality just by tweaking the code a bit. I can change permissions and so on here. If I want this one to be world readable, just do this, and that's it, and so on. So the file manager is pretty complete. I really like it, and a couple features are not really complete or really well done right now, like drag and drop and copy and paste. But other than that, it's very useful, I think, and it's super light. It doesn't make coffee, that's a lie. It doesn't save the world from white sharks, and it's not really finished. But yeah, for the rest, I think it's pretty cool. The mail client, because I wrote a mail client, I'm crazy enough. And it also has an embedded mode. This should be the regular mode, I think. Yes. So, and I have integration with some of my other tools, like the calendar and the to-do list, just like Thunderbird does. In here, and I could have more plugins, like for mailing lists and stuff. I have a beginning of one, and I could run Dovecut. Let's start it. Where are you? Shell root. Give me root. No, it's not this one. It's here. Okay, let's start Dovecut. And now it should connect. I can go offline and online again. It should be faster. If it works, I hope it does. Or maybe I have an issue with my password. Okay, anyway, okay. Maybe I cannot demonstrate MF4 right now without changing the configuration, because I found a bug and this is how I was trying to fix it. But yeah, this is Mbox support. So this is my local inbox right now. And I can show that it supports more than that. It has full preferences. You can choose the font you want to use. It has some more plugins if you need. and you can create a new account like this. Your name, my name is not A either, but that's fine. I could put your username here, password, the host name, and it's going to connect. It supports Gmail, of course. Damn it. 3 IMAP, and yeah, it's here, and you have it. Yeah, so there is a mail client. It's not fully usable, but it can send email, and if you use the compositing tool to CC yourself, it also you can also then move the message to the send folder, and then you have the send feature like this. And as you can see, there is also another interesting feature. You can do add field, and you can put any header you want conveniently, and it's going to use it. So this is also pretty convenient for pen testing, for instance. So you can also attach files and so on. Okay, it doesn't fully work. Let's say, sorry. So yeah, this is already quite something. It uses SendMail right now to send email, but I want to extend it to SMTP and other ways. Anyway, back to the slides. The PIM applications. So I showed briefly the to-do list and calendar inside the mail client. So they work standalone, and they also work embedded. So I can run just to-do, and I'm going to have my tasks here. And what is my mail client? Do I still have it? Yes. So I can show the to-do list here, and I think if I add a task, hi Fosdem, it should show it also here. Maybe not. No. Whatever. I can run it again, and it's going to do it. But it should really just refresh. Yeah, it's here. The calendaring application is right now not really complete. Doesn't do much, so it's useless. Don't have to show it. The web browser, I wrote a very simple web browser based on not only but WebKit. I can illustrate it again. I think I still have it here somewhere. Yes, it's this one. So as you can see, it can do SSL. It detects if your connection is trusted or not. I don't have the GitHub certificate in my trusted list, but for this it does. Saying this, yeah. So it can connect to proxies. It does multi-tab, multiple window. It doesn't save the session right now, but it can print, and so on. And it also features a couple more HTML rendering engines that one of them that I wrote, and it supports Mozilla and GTK HTML 2, GTK HTML2. So that's another handy tool, and that's that's where the online help browser comes from, here in normal mode. So yeah, can open this directly. I'm cheating a bit with the terminal emulator because really I'm embedding Xterm using the Xembed protocol. No, not Xterm, I want terminal. I'm trying to use meaningful names for everything, so that's why it's called all to do, terminal, mailer, and so on. Because I'm sick of having to remember however fancy name somebody used for another web browser or something. So mine is just called Surfer for surfing. So yeah, here I'm just embedding Xterm inside some tabs. I can run a new window and so on. So it doesn't do much, but if you want to have a full GTK user experience for consistency and so on, you can have it. It's there. Close, yeah. And it asks you nicely if you want to close multiple tabs. Yes. Okay, so the media player, I can play videos. I have a nice video of my 900 phone booting X. I can show it right now again. Should already be started somewhere. This one, yes. So I have a smartphone here which is running NetBSD, the Nokia 900. And this is a video of it booting. So using my media player, which is really embedding Employer right now, I can show it booting a bit faster than it really does. And there it is. You have NetBSD running X on this phone. Okay, so speaking of embedded development, I have also a simulator. So I can simulate other desktop interfaces and screens, which is very helpful because, as I mentioned, I want to target not only desktop systems but also embedded platforms. So I mentioned my file browser, which is on IDE, but I have originally intended to have a separate IDE, which is called Coder. And I want to demonstrate it now. So Coder really doesn't do much. It's really helpless, but it has a couple launchers. One of them is for the simulator environment. So it has a number of profiles, and I can choose to emulate, say, the Nokia 900. So it's going to use a screen resolution of 267 dpi, 800 wide resolution, and 480 high, like the original device. Then it creates a window of exactly this size. It's here with a black background, so I'm just going to run Defora on it. I'm going to run the desktop. Here it is. I'm going to run a panel applet, the same one that I have. Here it is, with the proper fonts according to my configuration, so it's a bit of scale right now, but it works, and I can run a window manager. And here you have your environment for working on embedded situations. And speaking of which, I'm going to run a terminal, full screen mode, and I'm going to use the embedded environment that I just built instead of the regular ones. So the regular applications look like classic applications. They have a toolbar, they have a menu, they have all of that. But in embedded mode, I'm running the same code, except I got rid of the menu bar, and sometimes I change the interface a bit. But other than that, it's the original code unmodified. So you have the same experience, the same functionality on your embedded device as you have on your desktop, which is very important to me because I find it frustrating otherwise. So here is the file browser with just like the toolbar, which can be made figure-friendly by just changing the size of the icons with your GTK preferences. And so for the rest, you can also have the detail view. You can right-click if you need, even if with the finger, there are ways for that to add support. This is all GTK2 based, by the way, but it also works, almost everything works with GTK3 instead. There are a few perks I have to fix. So this is the file manager. I can show the web browser also. In embedded mode, it has also just a toolbar. It has a simpler interface, no more thing at the bottom. Here it's in full screen. I can also do that. It's really in full screen, and so on. So that's the idea, to have the same code for embedded and for native. And nowadays it makes complete sense because these ARM processors are very efficient, and when I'm running my applications on them, they run flawlessly. Like, it's not a problem to have the same, since they're not in Java or anything like that. So yeah, that's for the embedded part and the simulator. Yeah, so it's pretty convenient to use now. As you can see, you can add your own profiles to emulate whichever interface you want. I think it's pretty cool. It's inspired from the Zoo project XOO, which is doing the same except with a with a skin around the interface, which looks a bit nicer, but it doesn't support changing the screen resolution. I mean the resolution in terms of dots per inch. And this is very important for me. If you really want to work accurately with fonts and icon sizes and so on, you need to have DPI exactly as it is on the device. So that's for the simulator part. The development environment also have a SQL console. So I wrote a few months ago a generic database abstraction library. And this SQL console is a graphical interface on top of it. So if I have enough time, yeah, I can launch it as well. I should have the IDE somewhere. I can start the SQL console. Here it is in regular mode. And I can tell it to connect to my local web server configuration, for instance, which is here. So it's this one. And the section I want is PDO for the PDO driver, connect, and then I can do select all from my, I don't know which table I could drop. This one should be fine. You're going to see my hashes, but they are couldn't place anyway. Oh no, I use SHA-1, cool. So yeah, this is a SQL user interface. and it supports SQLite 2 and 3 and Postgres. And it's reasonably simple to add some more. And yeah, you can dump the output, I think export and so on. Yeah, so it's also part of the desktop. I did that because I needed it, and you can also, of course, integrate it in some other applications and so on. So yeah, I can do SQL with a console like that, just like I would be doing it on Windows. Embedded mode. So I already mentioned it. It's exactly the same code. No more menu bar. More missing functionality is implemented through the toolbar. So to enable it, it's just a compile time flag. You add -d embedded uppercase to the compilation at compile time, and then it's going to build embedded mode for each application that supports it. And in package source, there is an option for this, which is called just embedded. So if you just enable that in your mk.conf, it's going to build the embedded versions of the packages instead. This is all meant to be used on touchscreens, and therefore also on smartphone and so on. Speaking of which, I could demonstrate, before speaking about this, the telephony application, because I'm also pretty proud about it. So connecting again to my phone. Once it finishes booting. Please connect. Yes. Okay. So here it says that I'm roaming because I'm not in my home country. Sorry for the Belgians. It's a nice country you have, but it's not. I live in Germany now. It's using the GPS network. It doesn't say the provider because of a bug in the N9. On other phones it works. This is the signal level. It's fairly accurate. And I have here two interesting sister icons. So the first one is to trigger more parts of the interface. This one is really embedded only. I don't have any menu bars or anything like that because it was originally meant to run as a phone. So this would be like displayed full screen on your phone, on your actual device. This would be the contact list. Right now I don't have anything because the N9 doesn't expose them over the AT line interface. However, I can show something else. In theory, I should be able to send messages, to send SMSs over this way. But it also doesn't allow me to do that with the N9. With some other phones it does, so you could just do that and send it, and it would work. So you could send SMS messages from your phone. And interestingly, more interestingly, I also have a plugin system featuring audio and so on, and one of these is called GPRS and allows me to connect to the GPRS network. And it doesn't require to be root, actually, because I'm using PPPD in PTY mode. I don't use chat, because I am already the chat interface to the modem. So I'm just launching PPP as a userland process under my own privileges without needing root. And since it's a set user ID binary, it's opening the PPP0 interface and gives me network access. So I just have to insert here the preferences for connecting to the GPRS network or 3G or whatever, it's all the same. And it connects me. Okay, let's burn a few euros. Yes, I want to. And so here it should connect me to the internet using the PPP interface. And I should be able to monitor that. Over here, if it allows me. It started PPPD, and well, yesterday in the train it worked. I had my DNS servers and everything showing up. And this is exactly how I connect to internet usually, using my flat rate internet profile in Germany. And so you can also have really convenient applications to connect to the 3G network on your BSD device, on your BSD system. It doesn't matter. And this is how you can do it, for one. Yeah, so that's the telephony application. Of course, it can also issue phone calls. I could use it to reach my mailbox and so on, using the dialer. No, not you. I even have some DTMF support, I think. Yeah. This is done not on the phone, but on this device instead. But it's nice to see what you're doing. Yeah, this was twice 5. Okay, so back to the presentation because time is running out anyway. What doesn't work? Yeah, this is like the sad part. Building on other platforms than BSD is sometimes a little bit difficult because as portable as I'm trying to write my make files, I'm automatically generating them with a tool that I wrote also. It's not always working directly. So I have a tool which I called configure, which is really not the GNU one. It's written in C, and it's very small, and it even has some security features. Not very complete right now, but it's more like a concept. I can actually illustrate it and show you how fast it does everything, unlike GNU configure. I have another shell where I prepared this. Is it this one? No. It should be this one. Yes, okay. So here I am in the libc directory of my operating system. I can run configure, and bam, it just regenerated my makefiles. And I can also do it cross-platform because I can say configure minus uppercase O for Linux or whatever, and it's going to do it. And now if I run make, it's not going to compile because it's going to build for Linux or whatever. Anyway, and I can do it for the whole system, the whole OS. It's going to work across everything normally. Oh yeah, verbose, sorry. It just did all of that without telling you. So it doesn't even want to scroll back all the way up because there is too much. I just configured like 50 projects for this platform in half a second. Not even. Yeah. That's the time it takes to reconfigure DeforaOS. Hi, GNU. Of course, it doesn't do absolutely everything, but it supports SmartOS to some extent. I mean, Sun, Linux, BSD, a bit Windows, and so on. So let's show a bit more of this. What did I want? What was my point? What doesn't work? Yeah. So my idea right now in package source is to force the use of configure before building any DeforaOS package, which should be not too difficult to do. It's not ideal, but yeah, it should help for Linux and other platforms. I have more demos if you want of the rest of the system, not only the desktop. Yeah, the window manager is maybe the one missing thing inside the desktop environment right now. I wrote one which is meant to run on embedded devices, which puts every application full screen all the time, but it's not really functional yet. I need help for this. Or I'm going to rip off Metacity or something. So this is a picture of my cat. I saw I had to do this. Okay. If you, to be honest, to be fair, it's not really a cat in the sense of the animal. It's more like my cat binary. It's because I wrote a disassembly framework, and it has a graphical interface, of course, since I'm crazy like this. And so you can disassemble F binaries like that. It's also part of the desktop, and you can scroll to whatever code. Whatever section you want. Here you have the regular cat from NetBSD or HBSD actually. Where's the text section? Well, whatever, you get the idea. You have to full disassembly here. It's not absolutely accurate every time, but yeah, I support a few different architectures. I can list them here. Yeah, so that's everything that I support. Not everything 100%, but yeah, you also have a user interface for all of that. I could take a Java file, a Java class file, and just open it with this, with a GUI. Yeah. So that's about the framework. Right now it's only in WIP, I think, but I'm going to import it as soon as I can. It's really meant to be integrated with the IDE to be just a big debugging environment, but it's not finished yet. But all of the pieces are there. I have a compilation framework, which I could also demonstrate, but maybe in another talk. Distributed framework is interesting too, even if it's very experimental, and right now it's completely broken because I wrote only half of it, and yeah, I cannot show it really. Privately, if you want, we can spend more time on it. I mentioned GTK3 already. I did some demos. I have a version of the progress tool in GTK+. I could show it too, but I would like to show off with my libc, I think, right now first. Oh yeah, I have integration with the PowerD mechanism, so if I just do that, disconnect myself from the mains, it should say, yeah, power saving mode. Well, it's not looking absolutely perfect, but then if I connect again, it comes back, and then it changes like the settings for the battery tracking and so on. Yeah, so I can show off with my libc, I said. So the libc was just born from a studying project, and I thought I would learn a lot more by actually having a working libc and not just printf, and so it works now. I have a libc which supports a number of different kernels with a number of different architectures. So on MacOS X 64-bit Intel, FreeBSD Intel 3264, Linux 3 architectures again 4, NetBSD a few more, OpenBSD also a couple, and Solaris. At some point I had a Sun machine, not anymore, so this is probably not working anymore. But this is the only libc I know that has support for more than one architecture. I mean, for more than one kernel and architecture combination. I mean, yeah. So I think this is pretty cool, and I'm also using it for other purposes. But if you want to see it built, and it's like this. Well, I'm mixing arguments. It's going to work. Yes. So this is how fast my libc compiles. No, it doesn't. Okay, let's rerun configure because I think I used Linux just before. Did it for Linux. Okay. This should work this time. And it provides me with a working system in theory. Why is this crashing? Maybe if I don't use J4. Yeah, it built, and I have my tests, and they pass, very nice, except one which I know should fail, and then I have my own libc, and I can check, for instance, ptrace. It really uses my binary, and well, maybe it's not the most interesting test I have written, but I could try standard int, whatever. Yeah, so this is all using my libc instead. With this I can compile, well it worked at some point, Linux applications from NetBSD without retargeting the compiler. Because I just force my libc to use the Linux definitions. I use -m32 with GCC to build 32 bits, and it creates me a working Linux binary on NetBSD without retargeting the compiler. So I think this is pretty cool. One side effect of using this, of doing this. Okay, what else did I plan? Documentation. Since I'm generating every documentation with GTK-doc, it's also generating myself the documentation for the base includes, for the system includes, and so on. It should be here. Give me help. Yeah. So this is generated. I think that's pretty handy. What else did I want to show? Yeah, the system. So I mentioned that I have a self-hosted part, and do I have QEMU somewhere? Yes. So here I have just booted Defora as built with the set of scripts that I provide, which look like this. I would run it now for you, but I don't have much time anymore. So you just run build.sh in the DeforaOS main folder, and you put these parameters, and it creates a working NetBSD image. Well, partly working because I have to input this manually right now. Okay, small issue with the keyboard. Damn it. Okay, this is not going to work. I should reboot it. Okay, let's yeah, but it's the image is right now booting on E instead of A. For some reason, it doesn't detect the boot/boot. I can boot it again. It's just because I used control and caps lock or something. So here I just built an image based on the DeforaOS libc set of utilities on top of a NetBSD kernel, and I have a very, very small system that cannot do anything right now. but I have a small shell and set of utilities and so on. This is just to demonstrate that DeforaOS really is also about like this self-hosted part, and that I want to eventually maybe have an operating system, but it's not the main goal. It's just, but it's there also. But you do not need to run the DeforaOS libc to run the desktop environment. Everything is meant to be individual parts, individual repositories. It's all on GitHub too. I can also show this. And on Defora, of course. So I have about 52 repositories online, all maintained by me, or got a couple contributions at some point, but almost everything is my work. And this is right now all GPL, and I'm going to raise a troll here. I'm using the GPL to annoy people. Most of it is GPL3, yes. Because I don't want to give out all of this work for free, so I'm using the GPL. Hi GNU. But yeah, I may switch to BSD at some point for some of that. And some of it is, some libraries are LGPL, of course, because I want people to use it. I don't want to be an ass. So yeah. But it still was a lot of work, you know. So now. And yes, this is Defora on top of a NetBSD kernel. So it's very simple, there isn't much really, and there are some bugs and many issues, but it was fun to create. So this is everything that I support right now. Well, actually I support a bit more, but I built a minimal one. So yeah, or a bunch of tools. So if you want to have fun, you can join Defora, you can run it as a desktop, you can hack on a completely new concept of operating system development, or on hardcore self-hosting stuff. I hope this was all interesting to you. I'm sorry that I was going maybe a bit fast and not taking any questions. Maybe you have 2 minutes? Okay, 2 minutes. So, yes.
Your libc, does that have multiple top ends or multiple bottom ends? Does it run on multiple kernels, or does it present different syscall interfaces while always running on the same kernel?
So it runs on different kernels, and it's a very good point you raise, because one of my ideas is to expose a single interface to the user land, regardless of the kernel. So really, I chose somewhat arbitrarily a single way to implement like the mount system call, which typically differs from platform to platform, in the libc. Can I show it here? Yes. And it's possible to do both, because the platform-specific parts are really, really small. So if you check in NetBSD, the AMD64 specific code is just 2 files, start and syscalls. And even if you read them, start is this big, like 2 pages. And the syscall one is also just a few syscalls which have to be implemented in assembly, and that's it. Okay, maybe it looks impressive like this, but no, it's just 300 lines. So this is one of the biggest ones because it's the platform that I use the most. But other than that, it's reasonably easy to do both, to either use the kernel that you want natively directly, or to expose a common interface for all of them. Anything else? My aim is to have fun. This is done already. It's been 10 years. I'm still doing it, and yeah, I like what I do. The aim is to save the world from GNU and no, from Google and Apple and so on. Well, when I started, they weren't really a threat, but now I don't like the situation anymore, if you ask me personally. Which is why I run Linux here natively, not Android crap. Sorry if you have one, but I don't like you. No, I'm just kidding. And yeah, I want to use the hardware that I bought with the systems that I like. So I want to run NetBSD on every shit that I have. And if it's open source, it's fine too. If it's native, even better. And I'm doing stuff like, I mentioned the distributed framework. To give you an example, I'm distributing OpenGL. So I'm taking a running binary, and I mean an existing binary. I don't modify it. I just hook the OpenGL calls it does. I redirect them over the network to another display somewhere else, which has like my server, which runs also almost unmodified. And it just takes these commands and issues them on the server. And I have a generic wrapper using the shell to do that. So it means I can have remote OpenGL code using a shell script. And it works. I have rotated a triangle from one device to another using a shell script, and it's doing OpenGL, like on the other end. And it's all native, serialized, efficient, all you want. And I'm also able to do this because I have a libc, because I can get rid of some of the complexity of the system. And instead of hooking __ NetBSD 6.0 because it's a compatibility wrapper for whatever version, I know I can just hook mount, or I can just hook whatever, and I know what it's going to look like because it's my libc. So I can do it and abstract every freaking call from the libc remotely, and I have my applications migrating from one host to the other. And I don't even have to recompile them. So yeah, that's the kind of fun that I'm having right now. So if you want to have the same kind of fun, I can give you a sticker. And I promise it doesn't bite. Yeah. Where are they? Where are my stickers? Here, yeah. Please, this is my new business card. So yeah, any other question before we close?
Let's close it here.
Okay. I'm exhausted anyway. Yeah, thanks. Back to you.
Thank you.